Welcome back to part 2 of angle theorems for triangles. Today we're going to talk about exterior angles and remote interior angles. So an interior angle of a triangle is formed when by two sides of the triangle. So the interior, that is the inside of your triangles. Okay? An exterior angle is formed by one side of the triangle and an extension of the adjacent side. So here's my one angle, and then I extended this out, and so this is a exterior angle. Okay? Each exterior angle has two remote interior angles. So the remote interior to 4 is 1 and 2. They are remote because they are further away. It's an interior that's not adjacent to, so it's not connecting to. They are opposite sides of it. Okay? So when I'm talking about a remote interior angle to angle 4, I could be talking about angle 1 and also angle 2. So it says there's a special relationship between the measures of an interior of an exterior angle and the measures of its remote interior angles. If I extend the base of the triangle and label the exterior angle as 4. So I'm just going to extend this out. So I have that line right there. And I'm going to name this one, I'm going to name it 4. So we know from the triangle sum theorem that if I take 1, 2, and 3 and add those three angles together, I'm going to get 180 degrees. So angles 3 and 4, these are forming a supplementary angle, aren't they? So angles 3 and 4, the sum of those two equals 180 degrees. So if angles 1, 2, and 3 equals 180, and 3 and 4 equal 180, the thing they have in common are angle 3. So that must mean that this sum of 1 and 2 is the same as the sum of, or the measure of angle 4. So, so angle 3, and then measure of angle 3 and 4 are equal to each other. Therefore, the measure of angle 1 and the measure of angle 2, when added together, is equal to the measure of angle 4. An exterior angle theorem states that the measure of an exterior angle is equal to the sum of its remote interior angles. Remote interior. Almost didn't fit in there. So we can sketch a triangle and draw all of its exterior angles. How many exterior angles does a triangle have at each vertex? So the best way to do that is to take and let's see, let's go with red, and then we're going to thin out the line a little bit, and we're going to draw a triangle. So when I am talking about my angles, 1, 2, and 3, these are my 3 interior angles. And they want to know how many exterior angles does a triangle have at each vertex. Well, I have one here. So we have 1. And then I have one here. There's 2. I also have one here. There's 3. I have one here. There's 4. I have one here, there's 5, and I have one here, so there's 6. So I have 6 angles, or 6 exterior angles. Okay? How many total exterior does a triangle have? So that is even that's even counting the verticals here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 total exteriors. Using exterior angle theorem, I can use it to find the measure of a missing angle. So they want us to find the measure of angle A and angle B. And we know A is 4A minus 4, and angle B is 3Y. And I know that my exterior angle is 52 degrees. I know that this is equal to the sum of these two. So I'm going to line it up as 52 equals 4y minus 4 plus 3y. I can combine my like terms here, so I have 52 equals 7y minus 4. Simplify to solve for y, and I get 56. 56 divided by 7 is 8. So I know that y is 8. Okay, so we've caught up with this here. Now they want to know what measure of angle A is and the measure of angle B is. I'm just going to substitute 8 in for y, and by doing that I find that angle A is equal to 28 degrees and angle B is equal to 24. So 28 and 24. Now, if I wanted to check to make sure that my math is correct, I know that 52 equaled the sum of those two angles, right? So if I take 28 and 24 and I add them together, I want to know, are they equal? So I have 52 and 52. Yes. So yes, it checks out that these two measures are correct. So it's a nice way to check it. All right, now we're going to try on the your turn number 8. We're going to find the measure of m and the measure of n. And we know that m is 5y plus 3 and n is 4y plus 8. And we know that our exterior angle is 146. So what I would like for you to do is to solve for y. Because I know that the remote interior, if I add the two angles together, I get my remote exterior. So I add the two, solve for y, got 15. Now that I know what y is, tell me what the measure of angle m is. Okay, so I substitute 15 for y and simplify that to 78 degrees. Now find the measure of angle n. So I substituted 15 in for y and have 4 times 15 plus 8, and that equals 68. So the measure of n is 68 degrees. Okay, take a look at number 5 and find the measure of angle C. I knew that the sum of the remote interior angles is equal to the exterior angle, so I used that to solve for y. Y is 10. So then I plug 10 in for y. 4 times 10 is 40, so the measure of angle C is 40 degrees. Find the measure of angle D. Because I already knew what y is, I just substituted 10 in for y into the expression, and I found that angle D is 76 degrees. Now they would like for us to find the measure of angle DEC. DEC is this angle right here. I know that it is supplementary to this exterior angle. And supplementary means the sum of two angles equals 180 degrees. Use that information to find out what the measure of angle DEC is. I chose to use the supplementary angle So I subtracted 116 from 180, got 64. So I know that the measure of DEC is 64. And then just to double check, I took 40 plus 76 plus 64, and I did get 180 degrees. Okay, take a look at number 6 and answer these three measures. So the measure of angle L, the measure of angle M, and then the measure of LKM. Okay, so once I found what Z is 7, I substituted in. I was able to find that the measure of angle L is 129 degrees, the measure of angle M is 32 degrees, and the measure of LKM, which is this one right here, is 19 degrees. If you have any questions, please make sure you speak with your teacher. Thank you.